So since we're talking about matrix multiplication, I want to mention this fact that we should keep in mind and remember. Multiplication of matrices is not commutative. So what does this mean? It means, in general, if I multiply A times B and B times A, I don't get back the same thing necessarily. So let's look at an example. So let's say I take the matrix 1, 1, 0, 1 and multiply by 0, 0, 1, 1. So if you compute this product here, you'll get 0 for this first entry. You'll get 2 for this one, 0 for that one, and 1. Now what happens when I switch the order? So instead I'm going to multiply 0, 1, 0, 1 with 1, 1, 0, 1. So if you compute the product this way, you're going to get 0, 1, 0, 1. So these two matrices, their entries are not the same here. This, in particular, the upper right-hand entry isn't the same, so these two matrices are not equal. Okay. So make sure you keep that in mind. We also have an identity matrix. So when we multiply any matrix by the identity, it leaves it the same. So IN is the notation we usually use for the identity matrix, or you might just see just I is the n by n matrix with ones on the main diagonal and all other entries are 0. So if you take a matrix of the right size, like you can multiply A times I or I times A, and it would just leave it alone, much like multiplying a number by 1 leaves it alone. So this works as long as A is any n by n matrix. So think about I, just like when you multiply by a number by 1, it stays the same. Same thing here. If I multiply by I, it leaves the matrix alone.